Hello everyone, welcome to this stream. Today we will continue some work on the Glasgow Digital Interface Explorer. This is a board that we are getting ready for crowd supply for making a campaign. Let me show you what that is. So Glasgow is this board. It is essentially a USB to X converter that utilizes an FX2 USB to USB controller chip. So it has an 8051 microcontroller inside and very powerful USB peripheral, so it can offload a lot of the operations into built-in hardware, so it can run very high-speed communication and put it on a port, like an 8-bit parallel port, and then have additional controls. And it has FPGA on it, which is this part here. It is an ICE40 HX8K, so it is a bigger version of the one that is on the Icebreaker, Bitsy or Icebreaker. Has more LUTs, but it has less RAM, but it has faster fabric. So it is always a trade-off of things. But in this case, it's more important to have faster I/O and faster fabric. It's not as important to have caching, because what we do here is we can connect to Gpio that can be arbitrarily programmed. And it especially has more I/O. Yes, so what Sylvain says is exactly correct. Having more I/O, and this part is a BGA, and it has way more I/O. That was really the important design spec. So on this board, we have level shifters so we have 8 GPIO. This is the main 8 GPIO. We have an Lvds connector on here, which is like a secondary function, but the main function are these two. And each of the GPIO, 8 GPIO, can be level shifted. There are settable, configurable power supplies for both sets of for each bank separately. So you can set output I/O voltage to an arbitrary number. Then you have ADC that can read the input voltage, so we can connect that. Then we have these two parts, which are I2C Gpio Expanders, used for setting a pull-up or pull-down on each of the pins separately. And each of the pins can be set as an input or output arbitrarily. So you can have a full combination of any of these pins being an input or output on each level shifter. So that's why we have so many level shifters on here, because each pin has its own level shifter separately. So each one can be set as an input and an output. Unfortunately, which would be really cool to have, there is not a part out there that has is a level shifter that has arbitrary setting of direction on each of the systems. You can set the full chip with 8 I/O as in full output or full input. So you can make all 8 input or output. You cannot make 2 of them input, then 1 output and another 1 input. That's why we have all 8 discrete level shifters on here. So despite this thing having flash on board for the bitstream, this is also an auxiliary function. We don't really put the bitstream onto the board. The system is meant to synthesize a new bitstream for the particular configuration that we need to implement the hardware interface we want for the target on the fly, put it on the board, and then use it from a Python framework. So that is what Glasgow is about, and Glasgow is fully enabled by the open source FPGA toolchain, because we can release the toolchain and the tool itself with the FPGA synthesis tools as part of it, which would be really hard to do with vendor tools that require licensing and a licensed server. They take up like 80 gigabytes of your hard drive or something ridiculous. Here you have a small toolchain that can synthesize a new bitstream to implement the hardware you want on the fly and interface to whatever you want. So there is a lot of already existing applets, and I am working on finalizing this board to bring it to production so we can have a crowdfunding campaign, which will be on CrowdSupply. I will show you everything on the computer in a second, and make the production of it. So before we dive into making a new revision of this board to improve manufacturability and improve pricing of the parts and reliability of the board, I would like to give a few shout outs to a few people that should get it. So first of all, this is the crowdfunding campaign, CrowdSupply. Subscribe to that. You will see in the bottom of the stream there is this Glasgow:/bit.ly link. This is the campaign link. I can also post it in chat here. Let's copy this over and put it in the chat. So that is the Glasgow campaign. So that's one. The second one is this wouldn't exist without White Quark. White Quark, she created the original version, she wrote the complete framework in Python, and then other people like Markan and Awigail made the new hardware revisions or designed the hardware over the time. And now I am pitching in to help with another revision of the board to make the manufacturability a little bit easier, as well as the batch production and the campaign. That's the job I took on. So the important thing is you should check out White Quark on Patreon. She needs support. She really is doing an amazing job and is having trouble to pay daily expenses. So this would be a very helpful thing. It's like definitely when the campaign goes live, some of the funds from that campaign will be going to her to support her, obviously. But for now, Patreon is a good way to support her and keep this project going. And second, because we are relying so much on the open source FPGA toolchain, I would like to give a I think that's the link. Yes. So I want to give a shout out to Dave Shah. He is an amazing coder and designer. Without him, a lot of the functionality in the open source toolchain stuff wouldn't exist. Just like Claire Wolf, who started the whole movement. Claire fortunately has a paid job and she can sustain herself, but Dave always requires some help. So if you want to be a supporter, check out his Patreon here too. So now the shout outs out of the way. Let's see what we need to work on Glasgow. So Glasgow also has a organization here on GitHub, so you can check out a bunch of the functionality. And the thing that I wanted to show you is what features it currently has. It has multiple applets that implement. So the main difference that I would like to, how I try to compare it to other devices and other tools that you might have, is usually a tool that communicates with digital I/O is constrained by either you have to build it yourself for the specific application you have, and all the hardware, and you cannot convert the problem. So what Glasgow is trying to do is convert the problem of hardware into a software problem. So it is, you don't need to spin a board and create a new I/O and new connection to a specific device you want to talk with. So this is meant to be a flexible hardware to a degree where you can at least prototype, if not just use it for the task at hand, without spinning a board and creating interface hardware for what you are working with. So the applets that exist is just UART. That's pretty simple, but it has automatic baud rate detection, which is a little bit more powerful than usual UARTs. Then SPI, you would find it on a microcontroller too, maybe. But then things become more interesting, where you will not usually have a microcontroller that has dedicated hardware built in to talk these protocols. And here you generate the hardware to talk to the specific device, even so that it works at the full speed of USB, and you don't need to use a logic analyzer that will run at very high sampling rate to read out, or and you cannot even write to that device. So you want to create the hardware on the fly for the device you want to work with. So in this case, it's like read and write EEPROMs, and then flashes, and then you get more and more interesting things. There's a full Yamaha OPL and OPM chip support, for example. This would be an interface that is not common in today's devices. You would have to bit bang it on the microcontroller, which is inefficient. And here you can create hardware that just directly talks whatever protocol of the OPL chips is necessary. So have the address bus, have the data bus, have the chip selects where you need them. The cool thing, for example, for like daily use, if you have a JTAG interface, there is an applet that automatically finds which pin is which and where you connected it. So you just take the Glasgow, hook it up to a JTAG connector, and say, please just detect where the JTAG is. It detects where the JTAG is, tells you what the pins are, and then you switch to applet that speaks JTAG, and you just can flash or read out a boundary scan. It's an incredibly powerful tool, so I am really excited. A lot of people are excited. People are so excited that they build them themselves currently, which is quite not a simple board to put together. And this means it will be a useful thing to have. So yeah, today we will continue some work on this, and I think the next several streams will be quite Glasgow centric, and we will try to push that project to a degree so we can finally launch the campaign, because I can't wait to get it out the door finally. So today I created a short to-do list for, this is the wrong to-do list. Let's see. So one of the to-do items was like consider removing the ATEC chip. I don't know why it ended up. This is an arbitrary order. I'm sorry if it is in a weird order. I'm not sure we will do that in this order. But yeah, so the ATEC chip is a security chip that can contain a certificate that can be signed to prove that it was actually made by 1BitSquared, not someone else. I am very torn about this because it does add a little bit additional cost to the PCB, and I am not 100% sure this will actually help much. The way I was trying to treat it is like, if someone else is manufacturing the boards, there will not be our company logo on it. That's how I try to treat it. So if you do, it's like I will make you take it down essentially. So that worked pretty well. Oh yeah, plain tasks. Yes, is the Sublime plugin. Yep, that's the plugin. Then we want to simplify a few things. So if you look at the board, we currently use this 8x gang resistor arrays. It turns out they are actually quite rare. It's like I did find some of the values. We need, I think, the 10K resistor and 33 ohm resistor arrays. For the pull-ups, I think it is 10K. Yeah, the pull-ups are 10K. And if I'm not mistaken, the 33 ohm ones are pretty rare and fairly expensive, which was a surprise to me. I didn't realize that. I was hoping, or I was asking Markan, who was working on the last revision of the board, to decrease the amount of placement on the board, because each placement does cost additional time on the pick and place machine. And so having less placements is a good idea. But it turns out that these parts are fairly expensive and rare. So we will be replacing the gang resistor 8x ones with 4x ones. So they are much more common. It's slightly more, yeah, but the 4x, the 4 gang, they are pretty common. I found all the values. You go on LCSC, you can find the 4x resistors in pretty much every value you would need. So 33 ohm for the inline resistance or the matching resistors, and the 10K. You can find them. You can find the 10K 8X on LCSC, but the 33 ohm is probably not. I think it's not on there, or the other way around. I don't remember exactly. Still, it was annoying, so we will be replacing them. Then the level shifters. It turns out it is possible to have the level shifters fit in here, even though they are SOT23, just standard SOT23. And I think they are cheaper, so we will be replacing those with bigger footprints. Then what else? Then we need to add locating pins on the Lvds connector, because I got those. I showed them really briefly on previous stream. So I got these from a different supplier. It's not... maybe on the microscope. Let's show you that really quick. So you see, this has a locating pin. The reason to have locating pins, the main reason why I want them is for the test jig. Because for the test jig, I will probably put a mating connector on the test jig itself, and I need the connectors on the Glasgow itself to be very accurately located. And that's why I want the pegs. But also, I wanted to find a source for these connectors that is not as expensive as Samtec, and I did, and we will have to probably adjust the footprint a little bit to match it. I don't have the data sheet on this computer at the moment, so it probably will happen on a different stream. So the next thing is, let's see what else would we need to do. So Lvds, this, so I want all the foot pads to be round rect for style points and reflow quality. So we did update these. I don't know why these are not updated here. But yeah, I did manage to submit these parts, all of them, to KiCad main library. Laplinkers, thank you for your subscription with Twitch Prime. I really appreciate it. That's awesome. Thank you. And yeah, there are several people that joined up. Ka Beckman, thank you for the follow. Anke Bodroin, thank you for the follow. Jandaloon, thank you for the follow. WBW72, thank you for the follow. Yeah, awesome. Nice to see you all. So many new followers today. Awesome. So anyways, this took me, with learning how to do all the KiCad stuff, about a week and a half to submit these upstream to KiCad. It's a little bit long. I'm sure it would be faster. I did look into getting the SOT23 stuff submitted because they still have the square pads in the library there. But I could not find a good standard that actually describes it correctly. So the problem is that the SOT23 standard, I found it in, I think, IPC, in the IPC standard. There is a form, but the dimensions are different than all the manufacturers are listing. It's super weird. I could not find a document that would match the like intuitively looking footprint that you would find in any of the datasheets for SOT23 parts. It's really weird. So I got stopped in my tracks halfway trying to just base it on the IPC standard and submit it upstream to make those footprints. So anyways, it's weird. I probably will just copy it over to the local library and add round rects to it. Maybe it's named something else. That's very possible. Yeah. Thanks. just building stuff. Thank you so much. So yeah, there we go. So anyways, we will be doing that. I think that will be the last step, to actually extract some of the footprints, put it into the local library of the project and convert them. I already made a bunch of changes. So, one question that people were asking. Wow, that staggered a bunch. Was that because of the... weird. Anyways, so there was a question today when I announced the stream. Why is it called revision C2? Shouldn't be revision C1? So the naming of the Glasgows is specific, and I hope I'm not misrepresenting it. It's like, if White Quark watches this, please correct me. So revisions are actually versions, in a way, of the hardware. So the letter is a major change in functionality and capabilities. So there is an A, B that are deprecated versions of the hardware. C is the first actually version that you should be using. And C will stay functionality-wise compatible forwards and backwards. So it will use the FX2 chip and the ICE40 HX8K FPGA and have the same pinout and the same functionality. The revision D, for example, will get more GPIO with level shifters, still the same hardware, more GPIO. Revision D will go from ICE40 chips to ECP5. And I'm not sure, I think it might be going to USB 3.0, but I might be misquoting that, but it definitely will go to ECP5, so way faster I/O, more I/O than this version. And the second number, and the number in this, is a hardware update version. So if you have C2, you know what the bill of material is and what parts go on here based on, if you have C2, this is exactly the hardware, and you know what the bill of materials is, what the footprints are, where they go, they are not moving. It is stable. It is released and it's stable, and it will stay that way. That's why we are working on C1. C1 is the released one that is currently the stable one, and we are working on C2 because we are changing some parts, changing footprints, changing the design of the board to a degree where you cannot take the same Gerbers and make the same thing. So, but functionality-wise, it will be the same as C1. It will be compatible, so you can consider the software side of things to be the same for C1 and C2. So I think that's how the mechanism works, and I hope that explains it to those that were asking this. Yeah, and so for the C2, what I already did, and this is not in the to-do list, I have some commits. Let's see. Is there... Nope. Let's see if I can find the terminal. So git log, yeah. So revC2. So these are the changes for revC2 that I already did. I bumped the revision. I removed the ESD diode ground pad. So these ESD diodes. So this is the ESD diode here. It protects the GPIO from ESD so that you don't fry things. And these parts are actually meant for HDMI, which is pretty nice. So they have single diodes. Let's see if I can open this up in the front end. I think this is the front end. Cancel. Check. No. I think I might be in the right place already. There we go. So you see there is just a bunch of Zener diodes, and we are not even using all of them. There are 3 more available here. So we are using those, and then we are connecting to ground so that if it goes above a certain limit, and I don't remember what it is, then it will conduct in reverse and shunt the overvoltage, and they will switch very fast. So they will protect whatever hardware is on the other end, so the level shifters in this case, and the pull-up, so the Gpio expanders. So they had ground pads here, and these ground pads were causing reflow issues, so that was very unreliable, so I removed them. We don't need them. We already are connecting ground on other pads, so whatever. Yeah, it is a nice small TVS, but the problem is the pads are very close together. It's somewhat finicky to to assemble. So yeah, it cost pretty much. I made this batch before Congress, and out of the 6 I assembled, only 1 didn't have shorts on them. Only 1 out of 6 didn't have shorts on the TVS diodes. I had to rework all of them and squeeze out like excess solder and stuff. So annoying. So yeah, the pads are gone. What else? Yeah, and then we want to add the anchors for the manufacturer text and the logo. So as I said, I don't want people to manufacture these with the 1-bit squared logo on them. So the 1-bit squared logo per se will not end up in the repository, or the design will not contain it, but I want to make it easy for me to add it when I make Gerber files without too much futzing around and introducing errors. So I will put this so-called null logo on the board so that I can just swap it with the proper manufacturer logo when I need it, and there will be a string in here saying it's manufactured by null, and if someone wants to manufacture it, they should replace it with their own manufacturer logo if they want to make a batch. But if you privately make it, just put your name in it. It's like made by me. The Gerber file generation is very easy, so it's like a lot of projects do release Gerber files for you to download and just upload somewhere to not introduce errors. I understand it, but it's like, is it really necessary? I don't know. It might, yeah, it probably makes sense for people that are unexperienced and can introduce issues in the Gerber file generation, but it should be pretty straightforward. Yeah, I will have to discuss that with White Quark, how she wants to handle it, but I definitely would love to have the anchor here so that it makes my life easier when so that the version in the repository is closer to what I'm manufacturing, so that we can keep updating it for those that want to make their own boards for their own purposes. If someone wants to have a nice assembly project and try their hand at assembling VGA boards, which is totally possible. So many people did that. Anyways, it's a good project to challenge yourself a little bit with SMD assembly. So I recommend that as a fun project to do. All right, so let's get started. Now we are already an hour in, and we didn't do anything. So the other section will be doing, it's 0.8 millimeter, I think. It's not terrible. Yep, it's 0.8. So it's not bad. It's really, really doable. I didn't have any issues with the BGAs. As I said, I had the weird issues with the ground pads on those DFN parts for the TVS diodes. That was a bigger issue than the BGA itself. Yeah, people are afraid of BGAs. It's like the lack of inspectability is the problem usually, and if you do everything right, though, it should work in most cases. I think the biggest issue was what Sylvain had at some point, where ECP5 packages were cracking apart, like splitting the laminate of the backing. Oh, that's so horrible. Especially, it's not a cheap part. But I think that might be related to moisture. I don't know. Correct me if I'm wrong, but that would be my go-to. That probably you want to pre-bake them at like 100 degrees C for a day and make sure that you drive out all the moisture slowly and then use it in reflow. They're curves for making moisture management. So that would be the first time I ever thought about this issue being actually a problem. Same thing with LEDs, though. Silkscreen? Yeah, no. Yes and no. So the problem with relying on silkscreen is you have to believe that the silkscreen is registered correctly, and I've seen this silkscreen being registered poorly many times. I now hand assembled a bunch of the HyperRAM PMOD modules, and I did have some that had bad registering of the silkscreen, and I essentially had to get a feel where it should go, and you feel you can nudge it still into place, into position after you place it. So it's not like you have to get it right on the first try. The solder paste will be moved around. If you don't make too much of a mess, it will still reflow and still connect together without creating solder bridges or cold joints. So you feel how you get on the hump of the solder paste and the pad when you move the part a little bit. It's just make small movements, small adjustments, and maybe try and dry first to get a feel where the pads are, what the correct position is at first. But after some time, you get a feel how it should work and should feel. And when you know, oh, it is now sitting in the solder paste. So you can do it dry, and you can always put it on the solder paste, remove it, clean it, put it on again. The alternative would be to zoom on my phone and check alignment. That's an option, yes. Look from the side. That's a very good idea. Then the home, like a simpler home solution for BGA reflow is to not use solder paste at all on the footprint and just put flux on the pads and put the part on there and just use the solder of the solder balls of the BGA balls itself to do the soldering. You wouldn't do that in production because that is not enough solder to wet the pad in most cases. This is not how it is designed to work. But it is a possible option. I use solder paste usually. It works. But yeah, then you have all the freedom and you can nudge it as much as you want until you are happy and put it in the reflow oven or on the hot plate and just be done with it. Anyways, so let's finish the to-do list. We are making a test jig, and Electric Eel, I think that's his name. Does it say here? Electronic Eel, yes. So he's in Germany. He's an awesome guy who put a lot of effort into making this, which is the Pogo test jig test harness. So this is providing, so the Glasgow itself is driving the testing, so it has an internal test already. But it also needs a wire harness for certain tests. And this is replacing the wire harness. So you can check that the current draw of the board is within threshold so that you don't have shorts. It does the Glasgow itself can use I2C to tell the board, please short my pins to do certain tests, or open the pins to do all the tests. So it can be all automated, and it comes with an indicator panel for the test results, which has just LEDs on it. So that's something I will need to bring up and test, and that's part of it. So we will have to order the I will order the Pogo pin tester very soon, hopefully. So I need to create screenshots of the board layout, mark the places where the Pogo pins go on the back of the board, because we do Pogo pins on the back, and then the Lvds will probably get a connector from top. So I need to do a quick PCB a screenshot of the back, cross where the Pogo pin test pads are, send that to the Pogo pin tester manufacturer, and they will make a mechanical thing, send it to me, then I will plug this in and then wire it together. So that's a project of its own to do the tester. So yeah, there's some steps in here that we might or might not do on the stream. I might just update you what my progress was, because it's more important to like move forward, but I want to share at least some part of the process so that you learn, hopefully with me, some of the processes of bringing a product to manufacturing. I think that is useful and why we are here. Anyways, all right. So a lot of talking. My throat hurts. I will have a drink, and then let's try to at least do some of the changes in here. So what is the question from the side? If absolutely needed and there is space, maybe put markers into the outside copper layer. No issues with registration there. That is a very good comment from Schneider. Yes, if you want something registered perfectly, you do it on the copper layer. And as an example, that's why, come on, that's why you have this here. This is a fiducial. And a fiducial is an optical marker for the pick-and-place machine to know where things are. And this one is a local fiducial for the footprint. And this is only exposed copper, because copper to copper registration will be pretty much perfect. You are not relying on the solder stop registration or silkscreen registration for it to be accurate. So you want the pick-and-place machine to be accurate to the copper, so you use registration markers that are in copper layer. All right, so let's do the resistor arrays, I think, because that means we have to change the these parts here. So I think they are all in this schematic. You have resistors here, input, output, and then pull up. So, oh, this is interesting. So they used a symbol. Is there a symbol for 3x? 4x, I mean. Didn't even realize that this. Where is that from actually? Device, RPAC 8. Interesting. Didn't know that this even existed. Device. RPAC. Our network. Huh. So these are networks. So this is an yeah, again, a little bit tangents while I'm at it. So you can have resistor networks where you have resistor ladders like this, for example. There are different ones. Network dividers. RPAC 4. Oh, with SIP. So single in-plane connections. Okay, cool. So let's do this. So RN3, we should... Why is the value not shown? The value should be shown actually here, in my opinion. I find the value on the schematic more important than for parts than on the unames on the schematic otherwise. But anyways, okay, cool. 33. Yeah, I just realized I need a short break. I'll be right back. And then we can continue just changing this. So this will be the job. Be right back. Sorry about that. All right, sorry about that. I'm back. Let's keep at it. So 33. Come on. Oh, this has to be like this. So that works. So we can just have two next to each other. So by the way, there's O and it rearranges the labels automatically for you, which is pretty neat. This is also 33, so you can delete this and then copy. I should have changed the footprint. Like this, and then edit this one and check if I can get a resistor footprint on here. Footprints. package, resistor, no, not relay, resistor SMD, R array 04024. So the alternative would be to use it from my library, but it's like we are not using my library in this project, so. Okay, so let's copy this and then reorient this. So one more thing, it's something you might not know. 33 basically means it's 33 ohm. The alternative is R33 or E33. E33 is an old notation, I think from European standard for a schematic. So if you see E somewhere, it's a resistor, and it's just a single unit resistor. So if you see some of my schematics, I use E as a designator. So to not have just a free floating 33 in here, I do use that sometimes, which I find somewhat funny, and then people are asking questions and I'm like, so by the way, you're learning a thing today. E is a standard from old schematics in Europe. So anyways, yeah. Ah, come on. There we go. Because historically schematics don't have UTF support. So you only use ASCII characters in schematics in most cases, so no Greek letters. No Greek letters for you. I don't even know if I can add that in KiCad. I'm not sure the font actually supports. I think it supports ohm. Maybe I don't think this actually exists as a character in here. So yeah, anyways, all right. So we just need the pull up. I think that would be it. So I can copy. And then 10K. So that's a familiar standard, the 10K, obviously. So one goes to the right. Right, so how was it? Oh, this is correct, okay. There we go. So I will rotate it to the right, backspace, move. Just this, like that, and then copy, and like that, and oh, come on. There's no space? Aw, no space for you. Nope, I want the label. Field reference, there. Will that fit in here? I don't know. Field value. That will be interesting if this will work. Okay, so let's see if we have RNs, other RNs in there. So this, we are inside this. So the cool thing about what we did, or what Markan did here in the schematic, is this is the bank circuitry, and it is in its own schematic sheet. So he didn't have to draw it twice. So he drew it only once, and then it copied over in here. So you can have linked. So how it works is you set the same file name for the schematic twice. So you IO buffer schematic, and then you have IO buffer B, and then IO buffer A as a name. And then KiCad automatically adds prefixes to the signals so that they are correctly named, and copies the devices, and then you get the numbering also doubled, so that each instance of the schematic keeps its own set of designators between the two sheets. So you can have duplicates of schematic layouts. Also, there's a plugin that allows you to lay out only one of the schematics and then copy the same layout to the second one, so you don't have to lay it out on the PCB itself twice. So that's very useful. We can use buses. So this is not nightly, this is still stable. In nightly, you can actually have an actual bus come out of a schematic sheet into another schematic sheet. So you can have a bus come out of a schematic sheet, so we don't need the single signals. Currently, this is single signals that come out of the sheet itself. You need it was on Twitter yesterday, or someone posted this on Twitter, so I don't remember what the name is. I would have to look myself. If someone in the chat remembers what the plugin is for layout duplication, drop it in there. References by... it depends on what you mean. What you have so you have those global labels also. So you have hierarchical label is, if you place it inside the sheet, it will be exposed as a port on the sheet one layer up in the hierarchical. Then you have this is the pin sheet for the outside to the inside, and then how did it go? And then you have global labels, and these are just globally available in all the sheets everywhere. You don't need to explicitly wire them up. I feel personally that they are dangerous. Oh, you don't even see it here, sorry. Let me just make this smaller for a minute. But yeah, so if you look here, this is a global label. This is just a net label. This is local. This exposes it all over the design, everywhere. Dangerous thing to use, in my opinion, unless it is power. Power is being distributed all over. This is common practice. Hierarchical label, this is what I use, and in nightly you have bus hierarchical labels, so you can export a bus from a sheet to the outside and wire it up to another sheet or to a component. So that's an improvement in nightly. Yes, exactly. Yeah, it's just like software, global and local variables. Yeah, and in software, it's also a best practice to use global variables. It depends on the situation, though. There are good reasons to use them too. Just like gotos in C. There are situations where it makes sense. But if you don't know what they are, don't use them. Yeah, look at the Linux kernel core. It's like, it uses gotos. And there's a good reason why they use them there. Different variables assigned to duplicated hierarchical sheets yet? What do you mean? Different variables? I don't know what variables you mean. Yeah, and they need naming. Anyways, I don't know. This is much higher level, like cerebral stuff to think about schematics than actually like trying to show design how it works. this is documentation. This is meant to document things. Think of it that you are documenting what the PCB will do. Make it really easy to read for someone who never seen that board before. That's the goal here. Don't make it convoluted and complicated and weird. It's like, oh, it's just here, and then where is it connected? This is the problem. You don't want to create a situation where it's like, oh, this pin here, but it's connected like 4 like layers up in some sheet somewhere randomly. That is a terrible idea. Don't do that. How am I supposed to find it somewhere? So yeah, what's different variables assigned to... Oh, okay. Yeah. Have a hierarchical sheet that, yeah, so have parameters so that you can change values inside the sheet. That's not a bad idea, actually. I'm pretty sure that's, yeah, that makes sense. I'm pretty sure this will be added at some point if it's not there yet. This is a good idea, I think. So essentially have modifiers for a sheet where it's like, oh, but the pull-up resistor value in here is 1K instead of 10K in this instance of the sheet, so that you can modify them and parameterize the modules that you're putting in there. Yeah, why not? That would be pretty neat to have, actually. Same thing with footprints, actually. Variants, yeah. I'm pretty sure this will be added sooner or later. Same thing with footprints. Footprints also need parameterization, in my opinion. Where why have like QFN, some types of QFN footprints? Why have 50 instances of different but the same footprints? Like the overall parameters are the same, but they are all generated with a script anyway. So why not say it's like, oh, I want a QFN with 9 pins per side or 10 pins per side, and just give me that footprint. Why not make it parametric in the first place? Yeah, I find that, yeah, Skittle. Skittle is really awesome. Yeah, I saw the presentation and KiCad of Skittle for schematics. The problem I have is I still think it should interoperate with graphical schematic design, so that you can at least document parts of this Skittle design with graphics. Humans are better suited for understanding graphical, especially for this kind of stuff. So we are going back and forth between software and hardware. It's like software needs documentation too. And it would, in many cases, you need graphical documentation of code too, like flow graphs, or have register documentation and this kind of stuff. And you have to create it separately. I wish software was more self-documenting per se in a way. We already have very good documentation for schematics. And Skittle is the complete opposite of that from the software world. It makes a lot of sense for complex designs to use Skittle, so that you don't have to connect a million pins on a bus all the time. But I feel there should be an interoperation thing where you can put Skittle scripts inside a PCB layout, and vice versa, put schematic designs inside a Skittle design. Yeah, and I talked to the guy who wrote Skittle, and he's like, his first reaction was like, this is a terrible idea. This is what I'm trying to get rid of, is schematics in general, because I hate them. But then I was like, but wait, what about these examples that I made? And it's like, yeah, there is a point to be made for that. So I hope eventually we will get interoperation between Skittle and schematics in KiCad, which would be really nice. Like embed Skittle designs inside KiCad KiCad files, schematic files. Would be really cool. But we are currently changing the format of the schematic files in KiCad. So let's wait for that to blow over first, because that will be quite a storm there before we add features like Skittle to it. All right. So I added, I'm really running low on water. I will have to pick up water very soon. So I don't think I have any more arrays. So what I can do now is press F8 and then annotate and then update PCB. Let's see what happens. There we go. And now we can the important thing here is I need to have enough space. There's this one trace that goes between the paths here, and I need the courtyards to not collide. So we will see how that works out. We still have plenty of space in here, that's good. Huh, funny. So we actually don't have enough space here. So I will have to route it somehow differently. Damn, that's not good. So this guy will have to no bueno, because I only can have one trace go through these here, and there is this guy that goes. So I have to make the connection. Sigh, big sigh. Okay, this will be an interesting change. Why is this connected to Q5? Oh, these are swapped for some reason. Oh, this goes all around to here. Why? Oh. Interesting. So I will have to do some via swapping. So these are swapped for a reason, because these are swapped. But maybe these have to be swapped back and forth here. Anyways, let's just place this stuff in here, and then we can figure out the routing later. The most important thing is to get rid of this and reconnect that. So yeah, as you see, I can only have one trace go between the paths here, and everything else has to work out. Yeah, and I have another 2 swap-the-roos here, so that will be fun too to fix. Yeah, there is more space between the pads on that other gang resistor. I could theoretically use go like this. Maybe bigger gangs instead of 0402s. Use Oh, 605s. Do I have enough space in here for this? In theory, it will be annoying. These fit nicely here. It would be good to have more space between the pads to have two traces that fit in here. Yeah. But we don't have that. Well, we will have to figure it out. It will be interesting. This will be colliding here. We will figure that out later. For now, let's just place these in the places where they belong. Like this. Yep. There we go. On our visual, let's see. We have several new followers. Yeah, great set. Thank you for your follow. I appreciate it. Derek Boom, thank you for the follow. Aki Vishale, thank you for the follow. And One Vishino? Rinshinho? Yeah, thank you for your follow. Thank you all, and welcome to the stream. Have you seen pneumatic arms for microscopes, sort of like computer monitor ergo stands? For microscopes? No, I have not. I'm sure that some stuff exists if you want to pay for it. This is the standard stuff. It's you need to adjust the height anyways for focus, so this is something you would do. The really nice 3D inspection microscope from Vision Engineering, they have spring-loaded heads. They are really cool. But this is even eBay versions are somewhat out of my range. They are like several $1,000s used. Even broken stuff from eBay from Vision Engineering is hundreds of dollars. It's like, these are really good microscopes though. I'm not sure White Quark will be happy if I just start swapping pins here. I think I will leave it as is for now. But yeah, it would be better to just connect it directly here. And the same thing here, probably. Oh, there's already a swap happening here. So we will see how that pans out. Yeah. It would be good to connect directly. How is this going here? It's there. It really depends on... Yeah, this goes to the back and goes to the vias. Yeah, we will figure this out. Just... Oh, and there is a via just directly under the dam. Yeah, we can't do that. I have to delete this via. Yeah. Yeah, what is going on here? I think there's... yeah, there's an internal... oh, God. There's a VIOB internally. So I will need to relocate it somewhere else because there was space under the thing. Yeah, I probably have to connect it here instead. You actually didn't like the Mantis. There's a monitor mount for vertical adjustment. Lock, unlock it when it's moving. Doesn't feel to move. Stay in place. Yeah, as microscope. Yeah, microscope stand arms are complicated. So let's do this while I'm already at it. And then let's place a via here before I forget. That should do it. These are yeah, I'm running out of space here, so that will be interesting. So there is some people that rerouted the board with the SOT23 chips, and it's like, oh, there's plenty of space on here. It's like, I'm curious how their layout is. It's like, if you want to keep the layout also clean, oh, I will rotate this 90 degrees and like have it here vertically probably. That will give me more space instead of having it horizontal here. Yeah, yeah. Let's put them back in the place where they came from first, and then I can do cleanup here. I have the feeling I will be doing a lot of changes first, then rip out a bunch of stuff, and then reroute it from scratch again to make those changes. That is probably an easier way of doing it than trying to finagle it into an existing layout. This doesn't feel like it will be fun to leave it the way it is. Is this the distance, right? Yeah. There we go. There we go. These seem to work fine. Same problem here. Let's delete this. I will have to probably, oh, I can. So one thing that Mark can put on here is all those namings of the parts. I really don't do that. On my designs, I never put the designators on the silk screen. It just forces you to use so much more space on the PCB to have those designators cleanly laid out. So I probably will just get rid of them on the whole board. Maybe keep the diode ones so that they have a little bit of a naming here, because it's more of a user interface facing thing. But especially considering that we have these tools, which is the bill of material tools, there's not really a need to have that showing. Let's see. There. So first of all, this is you can find the parts pretty quickly, and you can even switch over to which part it is, and then you can find them geographically on the design. And opening it up in KiCad to find parts is very easy, and especially you have things like that. You know, it's like these are new features of the bill of material, the HTML bomb tool. It's very useful. You can get all the signals and you can probe them. For debugging, this is just wonderful, and you see it from the back. So you can see which net is which. So 1.2 volt, 3.3 volt, 5 volt. Where's ground? Probably somewhere on the bottom. No. No net. There is no net somewhere. Oh, these are not connected pins, right? Why am I not seeing ground? Maybe I can just... yeah, there we go. Ground. So yeah, there's not really a point of having those designator on the PCB. There are very good tools that are secondary to that and make it very easy to debug boards. And especially because it's open source, you can just download the design. There's no point in having it on the board, to be honest. So I think one of the things I will propose is to remove those designators to make more space. Then I can squeeze out more real estate out of here and then get the SOT23s in here and stuff like that. So that's my current take on this. Oh, so the assembly these designators, it's assembled by a pick and place machine. So you export the placement positions and designators as a digital file with coordinates. So you are not programming the pick and place machine based on the designators on the PCB. Still in China, people seem to be doing it, but it's like, I don't do it. Why bother? It's like you don't need that. Yeah, for hand assembly as a kit, yeah, but still no, because with HTML BOM you see it geographically. You see where things are on the board. You are like, oh, I want to assemble this, so these are the parts that are 100 nanofarad capacitors, all of these. So you say this and it's like, oh, here and here, and then you look and it's very quick to realize geographically where these things are located. I seriously don't know how much is it actually worth of having the designators on the PCB for that. I don't feel like it will speed me up or add so much significant yeah, it's like, look at this. This is, as much as these chips take space, there are the designators in here. So, yeah? All right. Anyways, so a small rant about revDes. It's nice if you have space for it. Just put it in there if you have the space for it, but if you don't feel ashamed, don't feel bad. Just make a small board. I feel that small board is better. Smaller is better. There we go. Let's move this here. Bam. And then add a via. Bam. So the main reason for small tools, it's like, why even bother with tools like this to make them small? For me, it is being able to keep as many tools as possible in my travel backpack. That's one. Two, being able to work on Munich subway. I was commuting to school to Munich on the subway every day. It was invaluable to have small tools. It's like having a J-Link JTAG adapter in the normal size was so annoying. That's why I made the Floss JTAG, which was a tiny board the size of the Blackmagic probe now. That saved me, allowed me to work on Subway much more efficiently, because I just pulled out the ball of wires with the adapters out of the backpack, plugged it into my laptop and worked on it. and then put it in my backpack after an hour of riding on the subway. So having really small tools is really useful for me. Yeah. Oh yeah, yes. Sylvain is thinking of cool Inspect AR applications. Yeah, I like that. Having an overlay. I think I have to look into or contact Inspect AR, as I said before, and ask them if we can get an overlay running as an OBS plugin. So to have the camera stream coming from the microscope, get the overlay added. But the problem is, it's like I'm zoomed in so much that it might be really difficult to do. So I might need an additional camera in the back or something to either keep an overview of the design, or just this is the view that you see on stream that gets the overlay instead of my camera view, which is not as nice, but I don't know. Thoughts. But yeah, I have to contact Inspect AR people and try to figure out some solutions. vSense. Why is vSense not running on the back of the board? It could be running on the back of the board. Also, vSense is going through on the inner layer anyways. We will figure this out. We probably can run it differently. Anyway, so the pull-ups seem to be working. So pull-ups I can leave where they are, so that's fine. These here seem to be running fine. The question is, then I have only a swap here. I could swap it. Well, first of all, I think these arrays have to go vertical here in this space, and then vertical here in this space. But we will look at that after we change these parts. So this is this replacement. We can actually mark it as done. Swap resistor, mark is done. Then let's try to do the SOT235 swap. And I think that will be it for today, because I spent a lot of time just explaining extraneous stuff, which I will have to explain again on the next stream. Oh my god. But I hope we will get working on this faster next time. We'll be a little bit more efficient. So these are SN. Let's see if we can find those on LCSC. What do you have here? '74 series, 45. So what is the package? 363. So there are smaller packages for this. This SOT236, which would be, what is it? Just like 3mm width. And this one is 2mm width. So we could go with these. What is the pricing difference? So the cheapest one, yeah, it is like that. So the SOT236 is slightly more expensive. Slightly. And we could go with the SC76 or SOT363. Let's see, how big is it? Do we have a footprint like that? Yeah, we can put them away. So the RNs don't have to be close to each other. No, it's just I put them where the 8x RNs were, just to keep them in their relative vicinity where they belong. We can move them around later. It is a priority to keep the layout as clean as possible. So we will definitely put effort into keeping it nice and symmetric and nice and clean, and so that the layout is not a mess. That is, for me, very important. I want this board to look as pretty as it looked before, because Markan did a beautiful job of laying it out very cleanly. It's one of the few boards that people showed me, and I was, on the first look, was like, wow, that's pretty. That's really nicely laid out. And so I don't want to, I want to be able to live up to that expectation. This is a high bar, and I want to keep that bar there. I don't want to make a mess out of this. Or, yeah, let's just auto-route it. That's the solution, right? So, yeah. No, I want to keep it clean. But yeah, the utilization, we can make it cleaner, so we can organize the stuff a little bit differently. If it won't break too much of the aesthetic either. Okay. What did they say? 363? Oh, please. Really? Yes, it is there. Very good. It does exist. How much bigger is it? It's just insignificantly bigger. So we could go with these. Yeah, I will have to do some comparisons in pricing exactly, but these seem to be cheaper than the SOT23s. So let's compare them though. Let's put. Come on. Let's replace that. Recently used, this one. And then SOT23. Yeah. Dash 6. There we go. Yeah. So 1, 2. Yeah, it might 4, right? So if we don't want to collide with the connector like this, it would fit, right? Just barely, but it would fit. Also, this is an important label. The A is important. This is a user interface related label, so we don't want to nudge it around. So I don't really want to go that far up there. Yeah. So I think we will stick with these, with the slightly bigger but still small footprints. The problem with these guys is that they are finicky in reflow. It is easy to get shorts on these. So this footprint is already an improved footprint, so that it doesn't have as many shorts. But I think going with a footprint like this will be an improvement in reliability in assembly. So going slightly bigger might be a good thing to do here. We might just rearrange it a little bit, that's all. Yeah. No, it's like input is always welcome here. It's like I think that's why I partly do the streams. I did get from several people like Jordi before was sending in its like hand-drawn sketches. It's like, oh, you should try this layout, that might fix your issue. It's wonderful. It's nice to have people that are passionate enough to help and send in stuff. So we definitely have space here. We can get these closer together. These diodes are actually not very much used, but yeah, they would stay here. I am sure we can squeeze all of this in here. So let's first just fix it in the schematic and just go in here and change the footprint of the, so what is it? It's like U4. U4. These are the ascends, then SOT563, and we will replace that with packages SOT-SMD 363, because there's a hand soldering version of this. Oh my god, it's huge. Why do you need such huge pads for hand soldering? Oh my god, that's huge. Okay, so, okay, all right. So now that's saved. Yeah, we are, at Tonski, we are almost done. I am just, keep existing footprint associations, reassociate footprints by reference, no. So update PCB, update footprints, and update PCB, close. So now they are updated. Are you kidding me? They just fit on the same, in the same space? Oh wow. I am impressed. Oh my goodness. That is great. Okay, so we just have to like nudge the traces around and we are good. That is wonderful. That is a pleasant surprise. Okay, cool. So yeah. So we did two changes. Do we have any of this footprint more? I don't think we do. I think that would be it. So there is more work to be done like this. I think we will shut it down for today. So this is decent progress. I hope I got you time to buy a lottery ticket. Yep. That's exactly right. I think we will do the footprint for the Lvds connector next stream on Thursday. I might do some poking around if I have time, but because I have to do PCB assembly, so probably tomorrow I won't come to anything related to this. But yeah, on Thursday we will continue work on the Glasgow, I think. Unless something comes in the way. I retain the right to cancel the stream until the last moment, just FYI. But yeah, just get ready for Thursday. We will continue work on this. There will be a lot of puzzling in here to figure out how to lay this out. It shouldn't be too difficult, but yeah, that will be fun. So let's save this. I will check this off, and we didn't replace it. This should get like a, can we actually do this? Should be marked down in here. So this is cross through. That's the markdown for cross through, and we did SOT363 instead. Like this, something like that, and then let's mark it as done. Lvds connectors. So yeah, there will be a little bit more work. I will have to ask White Quark what she thinks about things, and then maybe post it to the channel of Glasgow, get some input, because I know the Glasgow developer communities has very strong opinions about a lot of stuff, so they will definitely have some input and tell me what I'm doing wrong here. There's of course some additional input to be done. So yeah, there we are. That would be it for today. As always, now a little bit time for advertisement and shameless plugs. As you see down there, the 1BitSquared store, check it out. We have some stuff that we sell, we build here as part of the streams. That is what is supporting me, and I appreciate you getting and using the stuff that we make. I hope it is useful. Well, it is useful for certain things. If you need some, get some. And otherwise, if you want to support the stream, thank you very much for the Twitch subscriptions. They are really appreciated, as well as the Patreon down there. If you have some spare dollars, please do. Every dollar counts. That really helps out. Without it, I would not be doing the streams. If the patrons weren't there and were supporting this, it's just a lot of effort and time and money. It's like buying a lot of supplies for showing stuff off. It's surprisingly spendy. Yeah, and then we will continue work on the Glasgow. I hope that's useful. And if you want to support that project too, that's the donations definitely help for me to spend all the many hours of preparing things like that. Selling hardware doesn't make much money. Just FYI. I should make software and just replicate stuff for free, right? Yeah, and otherwise, also I would like to give a shout out to a bunch of the Patreons that are so generous to support the streams and are in the shout out tier on Patreon. Thank you so much. And these are Jamin, Brennan Ashton, Drew Fustini, Edward Borden, Go Jimmy Pie, Jeff Wang, Jordi Parky Rodriguez, Kelly, Miha Benovets, Sid Price, and Tom Kelly. So again, as always, thank you very much for being here. And as always, if you have been, thank you for watching. Bye.